Okay, we are going to find the acceleration of the blocks and the tension in the string and the normal force on the whole system using only M, R, and G. So this is our system. We have a pulley right here, which is a solid disc. So it has a moment of inertia of 1/2 mr squared. And in this case, the mass of the actual disc is 3m. So its moment of inertia is actually 1/2 3mr squared, which becomes 3/2 r squared. Okay, we have two masses hanging from the pulley. One has a mass of 1m. The second mass is twice the size, so it's 2m, and it's all being held by a base of 4m. So if we were to let go of 2m, it's going to accelerate in this direction, clockwise, so we're going to go ahead and say that that direction is positive. Remember, the direction is only relative, so if you said counterclockwise is positive, you'll still get the same answers at the end. Okay, so in order to find the acceleration of the blocks, we're going to need to draw the free body diagram of each mass. So let's start with, well, there's three different objects here that are moving. We have mass 1, mass 2, and then we have the pulley, or we can call it the disc also. So we have mass 1, mass 2, and the pulley. Okay? So on mass 1, well, it's held by a string, so it's tension 1 upward, and it has its weight pulling down, so mg. Mass 2, we're going to call it T2, even though it is the same string, and there may be a different tension held inside of it, okay, because it is accelerating. So this is 2mg. And then our pulley, well, the pulley, we're drawing a free body diagram not to use the forces, but more to develop our torque equation. So due to the two tension forces, the pulley is going to experience torque on both sides. Okay, normal force upward. This normal force is not the total normal force of the system, it's only the normal force supplied by the pulley or the disc. And its weight, 3mg down. Okay. So we're looking for acceleration, so let's start with our force equations. Let's do our first one for mass 1. Sum of the forces. Well, we said clockwise was positive, so that makes T1 positive. Okay, our second equation for M2 would be, well, now T2 is negative since that would be going counterclockwise, so we have 2mg minus T2 equals 2ma. Let's go ahead and solve for tension in each of these equations. T1 will equal ma plus mg. And T2 is going to equal 2mg minus 2ma. So you'll notice that we have these two equations, but we have three unknowns. Okay, so three unknowns, which means we need three equations. We have two equations so far. This is our first equation, here's our second equation. So we're going to use our pulley system and our torque equation to find a relationship between T2, T1, and M. Okay, so we'll always start with our net torque equation, which equals I alpha. And we know the relationship between angular acceleration and linear acceleration. We know that it is linear acceleration equals angular acceleration times r, otherwise written as alpha equals a over r. So let's substitute this alpha in right here. We get I a over r. And the two forces that are going to cause a torque on this pulley are due to T2 and T1. T2 is going to cause the pulley to move to the right clockwise, which would be a positive torque. So T2r. T1 is going to cause a negative torque, so T1r. Okay, and we already stated what the moment of inertia is for this disc. It is 3/2 mr squared, so let's go ahead and plug that in. Don't forget our a, which is in the numerator, and then r in the denominator. Okay, this cancels one of our r's. So we're left with T2R minus T1R equals 3/2 MRA. Well, now you'll notice that R is in each of these factors, so we can go ahead and cancel out R. So we get T2 minus T1 equals 3/2 MA. So this is our third equation. Okay, so now we're going to plug, well, we have 1, 2, 3 equations and 3 unknowns, so we can plug anything in for anything else. So we have T1 and T2 already solved for, so the easiest thing would be able to plug T1 right here, in for T1 right here, and T2 right here, in for T2 right here. Okay? So I'll just write down what we're doing. Plug. Okay, so I'm just going to write 3 again. T2 minus T1 equals 3/2 MA. Okay, that's going to become, well, T2 is 2mg minus 2ma, so I'm going to plug that in right here for T2. And then T1 is right here, so minus the quantity of T1. Okay. So now we have one equation with one unknown, our acceleration. You'll notice that m is in every factor, so we can go ahead and cancel that out. We're left with 2g minus 2a, and then this minus needs to be distributed to both factors, so minus a minus, oh, that m is canceled, minus g equals 3/2 a. Okay, so let's combine like terms. So 2g minus g is just 1g. Negative 2a minus a is negative 3a, which is equal to 3/2 a. Combine like terms again, add 3a on both sides. You're left with g is equal to, well, 3a is the same thing in regards to halves. It's the same thing as 6/2, so 6/2 a. So 6/2 plus 3/2 a is 9/2 a. Okay. So when we solve for a, we get a is equal to 2/9 g. Okay, so that is solving for acceleration. So now we want to find T1 and T2. So in order to find T1 and T2 in terms of just acceleration, gravity, mass, and radius, we would plug in A, and for both A's in T1 and T2 for our first two equations. So plug okay, so our first equation would become T1 equals m times 2/9 g plus mg. Okay, so that is 2/9 mg plus, in terms of ninths, that would be 9/9 mg. So you get a total of 11/9 mg. So there's tension 1. Okay, we're going to do the same thing for T2. So we get T2 is equal to 2mg minus 2m, and then our acceleration is 2/9 g still. So we get 2mg minus 4/9 mg. Okay, well, we want to be in terms of ninths, so 2 would be 18/9. So we're left with T2 is equal to 14/9 mg. Okay, so the problem asked us to find the acceleration, which we did. Check the tension in the string, so T1 and T2, and the normal force on the whole system. So now we're going to find the normal force on the whole system. But in order to do that, let's find the normal force on the pulley alone. So let's look back at our free body diagram right here. Our normal force is the only up force, and we have 3 down forces. So if you guys recall, we add our up force is going to equal all of our down forces. Okay? And that comes from our second law. So we're finding normal force on pulley. Sum of the forces on the pulley are equal to normal force is positive minus T1 minus T2 minus 3 mg is equal to 0. So we get normal force on pulley is equal to T1 plus T2 plus 3 mg. Okay, well, let's substitute. We already found T1 and we found T2. So let's plug them in right here because we know that we want our final answers to be in terms of m, r, and g. So T1 was 11/9 mg, T2 is 14/9 mg plus 3 mg. And in terms of ninths, 3 mg would become, well, 3 times 9 is 27, so 27/9 mg. All right, well, we got a lot of ninths here, so 27 plus 14 plus 11. So here we have 25 plus 27. So we have 52/9 mg. Okay, well, that's just the normal force on the pulley, but now we want to find the normal force on the whole system. Okay, so we get sum of the forces is going to equal the 52/9 mg plus the actual weight of the stand itself, because we need to add that because that's its normal force. So 4 mg. And in terms of ninths, that would be 36/9 mg. Once again, a lot of ninths here. So we get 52 plus 36, which is 88/9 mg. Well, you guys might notice that this is really close to 90/9 mg, which if it were 90/9 mg, that is equal to 10 mg. Which if you go back up to your picture, you'll notice 4m plus 2m, that's 6, plus another 3, that's 9m, plus another 1, that's 10m. Okay, well, that's the total weight of the system. So our normal force we calculated is less than the weight of the system. So normal force is less than the weight of system, which means that our whole system must be accelerating. And if the weight is greater than the normal force, that means the whole system is accelerating downward. Okay, after watching this video, you guys should be able to do the last 2 homework problems that you weren't able to do previously to watching this.